Hello, this is Mr. Collier, and today we're doing arc length and sector area. So if you look at like maybe this diagram right here, this here is called a sector. Actually, let me draw the picture of that. Oops. Let me draw a picture over here. This, if we're at the center, and it's like a slice of the pie. That's called a sector. So we're going to be finding the areas of sectors. And if we look at a piece of the circle and just that length, that's called arc length. That's what we're going to be calculating today. We have formulas for them, and they're very logical formulas. This, I don't like the way it's worded, but you can have like A or alpha over 360 times 2 pi r is the arc length formula. Okay, and this is just a fraction. It's the fraction of the circle, right? For example, 180 over 360 is half. And it makes sense if you have 180, it's going to be half the circle. So this gives you a fraction times the regular circumference formula. And the same thing with the area formula. It's just a fraction of the circle times the circle area formula. So it's pretty easy to use. Let's look at this one here. It's asking you for the length, the arc length. So you do the 120 over 360, that gives you the fraction of the circle that it is, times the circle circumference formula. So 2 pi times the radius. Okay, and if we type that into your calculator, you get about 4.19 centimeters. Okay, the next one is asking you for an area. And it's 120 is that central angle. So use the area formula, the fraction of the circle that it is, times the area formula, which, yeah, these formulas are in the formula booklet, so let me show you what those look like. Here they are. So yeah, just like that, what fraction of the circle is times the area formula. And so the radius is actually given in this question is 5 squared. So if you type that in, you get 200 or 26.2 square meters, because it's an area. That's the area of this section right here. Okay, next this is a situation where we're given the area. And watch out, there's a pi there, don't forget about the pi. Given the area, remember area equals the fraction, so this angle is x over 360 times pi r squared. They give you the area, so we can put in 30 pi equals x over 360 times pi times the radius squared. And you could solve by graphing and typing it in, but you can solve algebraically. First of all, you can divide both sides by pi, or just cross them out and then multiply by 360. So we got 30 times 360 equals x times 13 squared. And we can divide both sides by 13, and we get 30 times 360 over 13 squared. And then you can type all that into your calculator, and you get about 63.9 degrees.